Hello. Let's see. So last stream the audio was a little too loud, but I'm gonna knock it down just a little bit. That's hopefully fine. It's hard to tell because like I've got, stream audio, I've got the audio in my headphones, you've got the microphone audio, it's kind of hard to tell like if everything's at the right level and all that, but just I guess, just fix it as you see it kind of thing. Speaking of too loud, it seems yeah, that's better. Cool. Okay, so what's today? Today's Saturday? It is. It's weird, I don't have work today. Usually the weekends are the busiest, so I work at a grocery store and like on the weekends people come in and buy their groceries. Because during the week you're at work or whatever, right? And so they usually put me on to work on the weekends because that's usually their busiest time during the week. But I got lucky, I guess, and I didn't have any work today. So that's why I'm streaming, because today's my day off. So I guess we'll just jump into it. I don't have much to say, nothing really different. Last stream we were working on this Kuwahara filter effect. Do I have that? I don't think I've got it in a page anywhere. But I can show it off here. So if we change this import, it's under Kuwahara. So I cleaned up a lot of the code off stream. And this file is, oh, I always do that. I think I caught it. Good thing I caught it early on. So here's the code. Here's the effect. This is what it typically is supposed to look like without any like post-processing applied. If you enable it, it's supposed to create this painterly effect. It's like a blurring effect, but it's supposed to look almost like brush strokes. And it's applied to the whole scene and applied to the background as well, so everything is getting that effect. And you can change the size of it here. Higher sizes, you get more blurring, you get bigger brush strokes. Smaller size, you see more detail come through. And the code for that is on the GitHub, which you can go to here. And I'll just show it off here. But it's this TSL code, so this is ran for every pixel, and this is just gonna grab, well, I don't want to explain it because that's not the topic of today's stream, but this is the very basic Kuwahara filter, and I intended to do the generalized Kuwahara filter and the anisotropic Kuwahara filter too, but those are really difficult. I tried implementing them off stream, and I think it's possible, it would be possible just to use it with GLSL or Wigzil, where you're just writing shader code, but this is done with TSL, and I don't know if, it's hard to say what the problem is, but it's more difficult, I think, to write it in TSL at the moment. And I don't know if that's just lack of experience or lack of knowledge, or I feel like it would be easier to write in just plain old shader code. That looks strange. I typically like to not have it all on one line like this. But anyway, so yeah, it was a little too difficult. And you know me, if something's too difficult, I just don't do it. Because I think my time is better spent somewhere else. I did spend a lot of time trying to figure it out. And I think, I mean, I can figure it out conceptually, it makes sense. but translating it into code is just kind of difficult, and especially translating it into TSL is difficult. So I kind of gave up, and that's okay, because you don't want to force something. If it's not working out, don't try to force it. You know, just move on to something else. Maybe you'll come back to it later. It may not be the end of the Kuwahara filter in this, you know, graphics project that I'm working in. But instead, I want to switch over to something that's kind of adjacent. It's at least another post-processing effect, and that's halftoning. So if you don't know what halftoning is, it's this effect. Well, it's not an effect. It actually comes from, pull up the wiki page. I never heard of that term. Yeah, it's supposed to reproduce this graphic effect that you would see from old printing. Yeah, so my understanding, and I didn't even read this, but I think what it is is that they would use blocks of dots to print, or I don't know if this is true or not, but it seems like this is kind of what it's replicating, is that you'd have these dots of color and stuff, and then the printer would just go through these dots and, you know, stamp onto the sheet of paper or whatever these dots. So yeah, it's like a screen, and then you apply multiple screens to generate this image. And, you know, it might benefit me to actually read the article and understand it. But here's a good example. You can see kind of like the dots and stuff. Handmade halftone plates. But we can simulate this or emulate this in a post-processing effect. But it looks pretty cool. And a good demonstration of the effect is in this little video here. So all these scenes here or textures here or images here have had the post-processing effect applied to them. And you can see, like, you can get some interesting results. And because it's a post-processing effect and all this, and you can apply it in a shader, you can apply it to a 3D scene. So it can be applied in real time. Yeah. Is that it? Oh, it's just looping. Okay. So that's what we're going to do, and we're going to run through this article here and just go from top to bottom. And this article is by the same guy that we looked at for doing the Kuwahara stuff. That's in this blog post here. So this is a good resource if you want to learn about post-processing effects. He's got a lot of interesting articles that are interactive and, you know, visually driven and stuff. So check that out. I'll put that in the chat as well. But I'm just gonna go through this blog post here from top to bottom and just kind of work our way through it and see where we get. So I've kind of skimmed through the first couple of like sections of this article. The very first thing that they talk about is how do you create like a grid of dots. So that's something that we can achieve pretty easily. What's that called? Here I've got the website already loaded up, or, you know, running locally. Let me change back to showing this page instead, or this app instead. Is it at halftone or what? Oh, it should be one word, I think. Let me change that. There we go. So let's set up our scene. That's typically what we always do in this thingy. And we can steal code from another app, because it'll be a lot of the same stuff. Don't have this, don't have this. Dang it. I hate how it does that. I gotta see what the problem is there, because it'll autofill here, but if I hit escape, okay, we're good. Okay, I don't know. Let's just do this. Okay, and then let's bring in all the imports that we need. We don't have this, we don't need this. We will need this. Don't do this, and that's it for now. Bring in these. Okay, let's make a scene. And let's make a camera. So this render pipeline, this is where we're going to set the output. So the way that you do that is you take the render pipeline and web GPU or the TSL and all, like the 3JS web GPU stuff is node based. So you can just set its output. Is it output or output node? Output node. So let's just set it to this, accepts any node that you want to pass in. So we'll just take the texture of some text variable that we haven't declared yet. Let's translate this back. Not very much, because the GLTF that we're going to use is pretty small. So we need a pass, and that's a, or let's see, I'll call that a scene. Or no, what is it? Text equals pass. I still haven't committed these to memory yet. I think it's text equals scene pass dot get texture node. That will give us a texture. We need to import this. But there's nothing in the scene, so let's put something in the scene. And that requires us to load a GLTF. So we need a URL for where we're going to load from. This this is actually an import, because Vite will take care of it. Located in assets, GLTFs, and then it's this one here. Let's make a loader. So this is also kind of like boilerplate stuff. I'm just going to take it from here. And it doesn't like that. What are you mad about? Oh, this needs to be module. Yeah, so it comes from add-ons. Okay, let's load that up and put it in the scene. So we do that with this code, which is here. Don't need to return it. I don't know why I'm returning it here. We're not using the output. Yep, so now it's in the scene, but we don't have any lighting in the scene. So instead of importing an HDR, I'm just going to use, I found this environment helper from 3JS add-ons. It's a new room environment. And it's like easy to, so you can either load an environment map, or if you don't want to like, use the network to load stuff, this is actually something that's created like in its constructor. It creates this scene and then sends it to a cube map and then uses that cube map as the environment map. So the way that you use this, here I'll show you the code at least. 3JS room environment. You create this PM REM generator, and I haven't really found out what this does or what this is, but that's another research topic to get into. So create one of these, you just copy the code, but it needs access to the renderer for the constructor. So you have to do this in the attachment. Bring that in from WebGPU. Now we got it, and then we can create an environment map from a scene. So we've got the environment here, the room environment. So let's copy this as well. Actually, we'll copy this. But this, from scene thing, it has to wait for the renderer to be ready. So you kind of have to do it in this promise callback. And setting the animation loop will wait for the renderer to be ready. That's partially why we save it in promise here, but we also save it in promise to dispose of it properly. So when the renderer is ready, we'll create an environment map from that PM REM generator to get its texture and set that to the scene environment. Now if we did it right, I think we should see something, but we don't. So let's debug it here. Texture is not defined. Oh, here, there it is. So I think this should be 2.5. I think that was the magic number. So there is our scene. This is our post-processing effect here. Right now we're just taking the texture, so nothing is different. This is what you would get no matter what. Like if you weren't doing any kind of effects or anything. Turn down the audio just a bit. So here's where we'll put our like special code or whatever. This is where we need to put it here. But before we do that, I want to make orbit controls, which are always nice to have. So that's new orbit controls. Dang it. Fix the camera. So now we have an orbit controls, and I have an attachment for putting it on the canvas. That's attach controls orbit. Let's import this. Now we should be able to, yeah, we can go around the scene. So there's no background, and that's because we didn't set the scene background. So you can kind of take a look at the room environment. If you do scene.background equals the environment, and this is the actual environment. It's not very pretty, but it's good enough for getting lighting. At the end, we might change to a different environment map. Okay, so everything's ready to go. What's next is referring to the article and seeing here. So the first thing they do is talk about how to create like a grid of dots. And you do that, how do you create one dot? So if you can create one dot, it's easy to create more than one dot. So how do you create one dot? Well, this is a function that you may or may not have seen. It's pretty ubiquitous. It's a 2D SDF for a circle. And the way that it works is you take your UV, which ranges from 0 to 1, and you shift that over so that the center, so now its range is -0.5 to 0.5. So the middle of that, the midpoint is 0. So if you want your circle to be centered, now it's centered at 0, and then you're checking your UV if that is within the bounds, well, this step here says, you know, if the distance here is within some radius, in this case, it doesn't have to be a radius. Step isn't about circles, step is about something else. But if you're within that radius, you set your value to 1 or 0, I can't remember. But if you're out of that radius, then it just sets it to the opposite. So that's kind of what's going on here. So we shift the UV so that the center, or the midpoint, from 0 to 1, we shift it so that the midpoint is now 0. We shift it left. Think about if it's on a number line, we shift it left. And then we're asking the current UV, so the UVs are just passed in to the shader. Is that within some radius? The way this length function works is that it's just the, what do you call it? The Pythagorean, or it's like the hypotenuse or something from 0, 0, I believe. But anyway, that's kind of the idea. And then here they're just mixing two colors. So yeah, this mix will take in like a parameter. The last parameter is the t value. So I think this is linear interpolation. So if you're at 0, you're fully white. If the t in circle in this case is 1, then you're going to be outside of the radius and you're set to black. So let's just copy this. And we'll make this a function called main. We'll bring in fn from PSL. Okay, so this UV, that's just going to be our UV coordinates. Can't do minus because we're not in GLSL or Wigzell. So we do dot sub. Here, step or length is actually an import. Step is an import. Let's put this to 5. So that's the UV goes from 0 to 1, so halfway is 0.5. This needs to be const, so we don't have types like that in TypeScript or JavaScript. And this is what we're going to return. So let's make a vec4 out of this. We need to bring in all these imports. Okay, and now down here, the output here is no longer just texture, it's just going to be main. So that's going to give us this circle. And you can see that it's stretched because the canvas size is wider than it is tall. So to compensate for that, if you wanted to, you would have to divide out the aspect ratio. So that's how you do that. If you wanted to make a black circle and a white background, you would just flip these. So now we can draw one circle, that's nice. How do you draw more than one circle? How do you make a grid of circles? There's this fract function, which will take a number or float as input, and then it just returns the fractional part of that number. So here 1.1 returns 0.1 and so on. And you can use that to create this grid. So what you do is you scale up your UV. So normally it ranges from 0 to 1. Depending on how many cells you want in your grid, you multiply it by the cell size or the grid size. And then you take the fractional part of that like new UV. So normally UVs go from 0 to 1 in both directions, X and Y. So if you multiply this by some grid size, let's say 8, let's say G equals 8, so we'll multiply it by G. Now we're going to go from 0 to G. So in this range, you multiply 0 by G, so get 0, 1 by G, you got G now. So now your UVs go from 0 to G. And then it's however many pixels are within that grid size. Or, you know, 1 is like all the way on the right, 0 is all the way on the left. But now we're going from 0 to G. But we can just cut off the fractional part of the UV now. So you do that with fract function. Where is it? Yeah, so this is making sense. So what it does now is you've got 0 to G, but you know this is a integer value, right? So in between you've got 0, 1, 2, 3, all the way up to G, right? And now if you take some number in between here, taking its fractional part will drop it down. Like now this is kind of like a normal UV. These are like UVs within your like range now. So this is like 0 to 1. Take the fractional part. Now you got like a normal UV again. From 1 to 2, if I had like 1.6, 0.6 here would be my UUV. So the numbers between each of these is kind of like the fract part of it is kind of like getting it back to your normal 0 to 1. I hope that makes sense. And then you've got G number of these. So this is super easy to do. You take your UV, you multiply it by your grid size. Let's take in the grid size as a parameter. And this is optional. So multiply it by grid size. That's our new UV. We can just pass this right in here. But we need to shift it. And we need to floor it, or take the fractional part of it. Yeah, where's the code? Right here. So you're taking this, and you're taking a fractional part of it, and then you're shifting it again so that it's from negative 0.5 to positive 0.5. And then let's get this back to this. So now this is 8 by 8. And you can change this grid size. You know, if you did like 32, now there are going to be a lot of them. If you did 128, you know, the higher this goes, the more white it's going to be. Even if you did just 1, there you go, you're back to where you were. This will be 2 by 2 and so on. But now, how do we color these? So if you want to make that effect like this, where do we get our color from? And that is going to be where we bring in this texture. So we've got the output of the like scene, like we rendered it to a texture, and now we can sample from that texture and apply, like how we do the sampling is going to affect how we apply the color to these circles. But before we do that, we want to pixelate the image. So here's the original image here. If you pixelate it, and we can change the pixel size. I guess you don't have to pixelate it. Oh, okay, yeah. So if you don't pixelate it, you can see here, in each of these circles, you can see more than one color. That might be a neat effect. I think we'll start there and then we'll pixelate it. If you do pixelate it, now the whole circle is one color. And that's because this pixel size is equal to the same size of the circle. Um, yeah, where's the grid size? Well, here we don't have a grid size because we're just using the pixel size, I believe. Yeah, here, we'll get there. So rather than mixing two colors, we'll just take the texture. Well, let's see, how would we do this? Okay, so the color, okay, I see what you're doing. We get the color, that's going to be sampling from there, and then our like new UV is like that. So here we'll probably take in the texture as well. I'll make that something you must pass in, and then here we'll say that these are options. So the text is a texture node, and then here we've got options. Options is optional, and that's a partial of this object, like that. So we're sampling the texture, and then we're sampling out the new UV. I'm gonna bring in texture node. Okay, so now we still are mixing, but we're mixing color and then this kind of like black color. What is black? By our circle. Oh, what is it? Oh, this needs to be mixed. Is that right? Let me bump up the grid size. Oh, here we can just pass in new. Come on. So our UVs are off. Let's see what's the problem here. Where is it? Oh, duh. Need to pass in the texture now. It's always something silly. Well, that's an interesting effect. I didn't expect that, but that's cool, I guess. Um, Thinking, how do I do this? Is this just UV? Okay, yeah, that's what it is. This is so weird. And then circle, let's see, circle as a float. So if, oh wait, can't do if. We do if. What I want to say here is, you know, discard the fragment if it's outside of the circle. Wait, I kind of want to switch these around too and see what happens. Oh yeah, it's like a mask effect. Hold on one second. Ooh, this is some boss music for sure. I don't think I've ever given this an actual listen. Let me look at the TSL docs for what step returns. Step. Generate a step function by comparing two values. Okay, I know that. But what's the return type? Well, I guess it's float. This mix takes a float. Float or number. Oh, I know, I could just pass in 0 here, right? Now it's got transparency though, so we'd have to accommodate for that. See if this will work. So if color dot equal the color is 0, then we'll discard. Otherwise, we'll return the color. Okay. Equal does not exist. Oh, it's... what is it? What did I do with it? Oh, the circle. Okay, this seems to be 1, I guess. I don't know, I don't really like comparing floats. So I wonder if I could just do Boolean. Is Boolean something I can use? Okay. Yeah, so let's up the grid size. Or maybe even more than that. Okay, so like I mentioned, each of these circles is just taking the color from the texture that we pass in. If we want to make the pixel one solid color, or make the circle one solid color, you'd have to pixelate the image, and then depending on your pixel size, like, you know, now every pixel, let's say, is 8 units by 8 units. That's going to be your circle size. So, I'll show you how to pixelate an image in a moment. Here we'll take in same kind of idea, take in the texture, make that mandatory, and then our options, say pixel size, or let's just say size. We'll set that equal, whoops, equal to 8, and let's give these types. So texture node. You don't have to pass that in. That is partial. Size is of type number. Oh. Okay. Now here, so the way that you pixelate an image is, you know, normally pixels are 1 unit by 1 unit. To get a larger pixel size, you need to scale that up. Now, I'll show you the math, and then I'll try to kind of explain where it comes from. But you've got this pixel size here. This resolution is the screen size. So pixel size is a vector 2, and resolution is the width and the height of the screen. So let's just work in the X for now. And remember that this is going to be fed into the texture function here, which its second argument is a value from 0 to 1. That's the UV, that's the index where we're going to sample the texture. So we know that in the end we need a value from 0 to 1. But jump over here. So normally the UVs go from 0 to 1. And let's say that our screen size, so this is UV up here. I'll make this bigger. And then our screen size will go from 0 to S, let's say. So that's screen. Actually, let's call this W because we're just looking at the X at the moment. Okay, so this is 0 to W. So we want to chop this up into segments. So, you know, in order to do that, you would divide by your segment size. Let's say that the pixel size here, just for example, is equal to 8. Okay. So if we just take W divided by 8, that'll give us something in terms of screen size. We would need to divide by the width. Trying to think what the next step here is. I know that if you take the pixel size and divide it by the width, here, let's say that the width is 800. That's a good, sometimes it's easier to work with like actual values. So width is 800. And normally your pixel size is a value of 1, right? Now each of these ticks, you know, you got 800 of these pixels. Well, I guess it's in this range here. All the way up to, you know, number 800. That's at a pixel size of 1. So each of these has a length of 1 over W, or 1 over 800 in this case. Now if you wanted to scale this up, you would multiply by, you know, some value. That's an 8 there. Or an 800. You would multiply the numerator by some value. So let's say our pixel is 8. That's what we're going to multiply by. So multiplied by 8, that, you know, if you reduce this fraction, it's 1 over 100. So each of these guys, there's going to be 100 of them, because each of these lengths is 1 over 100. And to get to the full 800, we need 100 of them. Well, width is, you know, the UV of 1 or whatever. So we multiply, and now we know that we got 100 of them. That's if the pixel size is 1, or is 8. If it's a size of 1, then, you know, we've got 800 of them, and that's the normal, like, width of the screen. So the, let's call it, I don't know what to call this one. In the example here, they call it normalized pixel size. So let's call it N for normalized. Here. So N is P over the width. That's the normalized pixel size. That's what they're calling it. I don't know if that's what I would call it. But what do you do with this value? Well, you take your UV, which ranges from 1 to 0, and you, oh sorry, from 0 to 1. Now I can scale this up, I can scale this down, because 0 on the left here, you know, multiplied by anything is still 0. I can have this number go from 0 to n, or, you know, 0 to 1 over n. And they're taking the UV and they're dividing out this number here. Dang it, where is it? I keep doing that. So if you divide by n, now we've got a number that goes from 0 to 1 over n. And remember, n in this case is 1 over 100. It was p, which is 8. 8 on the top, and then width is 800 here. 800 on the bottom. 8 over 800 reduces to 1 over 100. So now we've got a number that goes from 1 over n, or a number that goes from 1 to 100. Meaning that we've got 100 pixels to work with. Now, this will be some fraction in between. Where is it? I'm gonna get rid of these. Yeah, so the UV goes from 0 to 1. We divide out that number there. Hold on. We divide by n. I might have skipped something here. This will be 1 over n. N is equal to 1 over 100. Yeah, so that's 100. We floor that. 0 floored is still 0. You got numbers in between here that are also getting floored. But remember that the UV is some 0 to 1 value. So when we multiply it by n, we're probably going to get a float out. And that's why we need to floor it. And that will bring it to, you know, this is a row of pixels, or whatever. Each of these is a pixel. If we multiply it by that n, now we've got something in the range from 0 to 100. But we need to pull it back. Maybe we didn't get a full number here, and we probably didn't because the UVs go from 0 to 1. So the only whole numbers in that range are the first one and the last one. So we know that we've got some float out of this operation, right? But we need to get a... when you floor it like this, you're bringing it back to like not a whole number in this case, but you're bringing it in such a way that it is like at the start. Everything in here gets mapped to this start value by flooring it. You know, you get an integer out. So maybe we got a number. Let's say that our value was like 0.25. We multiplied it by 100. Oh, that's not a good case. Well, we have to do this because, so in this case, yeah, let's do something like 0.111. Multiply that by 100, you're going to get this number here. And then we floor it, we're going to get 11. So we're on the 11th like pixel. Our pixel size is 8. We're on the 11th one. And that's where we're going to sample the texture. But we have to turn this back into a number from 0 to 1 because the texture sampling expects a number from 0 to 1. And that's the last step here. You multiply it by that 100. Or 1 over 100. Right? So if you had a number, if you pass in 1 here, you know, we're on the last pixel. Or UV, we got out of a value of 1. Okay. Multiply that by 100. Or that's still 100. And then we divide by 100. Because that's what the end value is. Or, not divide, sorry, we multiply by 100. Or, hold on. You can kind of see where I'm going with this. We get, our UV was 1. Go over here. UV was 1. We divided by 1 over 100. That gave us a value of 100. We floored that, got 100 out. N is 1 over 100. So 100 divided by 100 would give us a value of 1. If we had a 0 here, it would get mapped to 0. And everything in between gets mapped to, you know, numbers in that 0 to 100 range. We need to scale them back down to 0 to 1. So I hope all that kind of makes sense. I don't know if I would have ever discovered that on my own, but it's a lot of like little math tricks and scaling and or mostly just scaling things. The way that you do that in the code is pretty similar, pretty easy. Here, yeah. Let's say that UV equals UV. Well, I'm not going to pass in UV. I'm just going to say that the UVs are, you know, your normal UVs. So our n is equal to the size divided by, size is a normal JavaScript number, so it's divided by the resolution, which is screen size. Well, you can't do this because screen size, if I could import it, Dang it, where is the... There. Screen size is a vector 2. And what we need is a vector 2 on this side. So we take this, and we're just going to make... like in our case, this is going to be the same for the X and the Y. You could have pixel sizes where they are not the same, and you might see how that looks in a moment. But for now, it's going to be a square. So this is our UV, or let's start in. Okay, and then we'll take our UV dot divide by n. Okay, and we'll floor that, so we can do that on this side. And then we'll multiply it by n. And then we'll return texture text at that, let's just take UV, what do they call this? UV node. Let's just call this index, or I for index. Bring in that import. Screen size. Oh, yeah. Can't do divide here. I'm not even doing divide, but can't do divide here. We gotta do actual div. Now this should pixelate the image if we use it. So over here, right here. Yeah. So now it is pixelated. And the size here we can control if we want really big pixels, like that. If you set this to 1, you don't get anything because, you know, the UVs all got mapped to what they already were. Let's do a value of 8. So that's our pixelate. If you wanted to do, you know, pixelate, yeah, math, more math, everything is math. What's going on? How are you? This looks really nice, I think. You know, with the iridescence on it, look how shiny and shimmery it is. So this is the whole idea behind pixelating this guy, is that if we switch back to the dot effect, there's more than one color in these dots. And you can definitely see that if we go to a really big grid size. Or sorry, a really big grid size up here. It's so big that it doesn't do anything. Yeah, there we go. But we want one color in here, so we would pixelate it, and we pixelate it by the grid size. So before we do the sampling, we need to pixelate the image. Yeah, so let's kind of combine these two things. And I kind of want this to return like a UV. So rather than actually, you know, returning the texture, let's do that, and then we'll return this. That way, oh, don't need this. That way up here, we can say that the UV is going to be pixelate of, what is it? Size is 8. Oh, let's call it grid size. And then that's our input here. Let's bump up this value. Oh, this needs to be options.grid size. Right? No. Oh, I know why. This needs to be an object. Okay, that wasn't quite right. But I think what we do is we pass it up. So this is kind of like applying two effects. What do they do here to get this to work? This is the Luma one. Yeah, I think this one's a little bit similar, or a little bit simpler. So this is the same. Let me trace this back. We get our UV. Oh, this is different. Yeah, this grid size. I don't think this is gonna work, no. Oh, hold on. Why didn't it tell me that my grid size is... Maybe it did. Yeah, this is size, grid size. But I guess it still did work. That's strange. Yeah, let's bring this to the top. So that's what they're calling UV pixel. They take the texture of that UV, the color, that's the texture. This new UV. Here's where they're doing something different. So they actually return the in here. So let's bring this up here. Call this size. I might get rid of that pixelate function. Okay, here's our in. Now the UV is in, or let's see, it's UV dot div in dot floor dot multiply by in. Now that's the UV, and that's where we take the texture. Here, we don't do this. This is UV. That's all the same, so I think we can actually move this down here. Oh, now I'm not doing any fractional part of it anymore. So this needs to be... Where do I take the texture? Right here. So the dist part of it, that is UV divided by... Oh, okay, so we do have to put in up here. That's UV dot div in, and then we fract it like that. But our size is not right. So let's move this into a variable. We'll call that cell UV, like they do. Cell UV there. Okay, let's see. This is in. We calculated here uv.div in dot floor dot multiply by in. I guess this is right because should be 100 of these between here and here, or whatever the width is divided by size. We jump this up to 16, we should see smaller ones, I think? No, bigger ones. Okay, so each of these, I believe, is 16 pixels. So this isn't really the grid size anymore. This is the circle size. Whee! Shimmery, shiny. Now you can control the size of this radius too. That's what they're doing here. Is U radius, or is it? So you can control the size of the radius here. At full amount, you know, they're touching each other. So if we add that effect, that'll be a parameter. We know that it must be between 0 and 0.5. Let's just say that it's 0.5, and it, like, if they don't pass it in, and then when we calculate here, yeah, they're only using the radius here. So this smooth step is a way to get like almost like anti-aliasing on your shapes. But if you pass in the radius, I like it at a smaller size. Let's go with like, what was it? 8 or 16 looked pretty good. But now we can like link this up with a uniform. Let's do that. And let's actually go back to step. We'll do this. So we'll say that the radius is going to be a uniform, initially 0.5, or let's do 0.25, and the size is 16, also uniform. And now the options here we can pass in is the size and the radius. I need to import these. I'll probably have some imports I'm not using at the top here. And then here it's going to say that uniform is not assignable to number. So these probably should be nodes. But how do we use this? This is float or number, so the radius here should be float or number. That's not exported, is it? Yeah, it's not exported. Let's just steal this. I know node is exported. What is this? Kuhara? Don't need that. So something like that. Node will bring in. Oh, we can't because it thinks that it's a DOM node. But here, so it's happy with radius, and now the size. How do we use size? Right here. So this vec2 number or number. I think this is also overloaded. Yeah, you could pass in a number or this node thingy here. So I believe that should be the same idea. We can say that this is this type. And same thing here. Okay. Put this back to 5. Now we got these uniforms where we can modify them. So let's add some controls for that. Yeah, this has class, relative, in our pane container, contains the pane. This is absolutely positioned, top 2, right 2. We'll attach a pane to it. Bring this import in from here. Add binding. Here we're going to bind to size, and that's the value, and label of. I want this to be multiples of 2. I don't remember how to do that. Is it text? No. Point. Oops. Where did it go? There it is. How do you do like a select? I don't remember. I think it is string. Okay, here it is. So label here is going to be size, options, these are just going to be 4, 4, 8, 8, 16, 16, and then I guess we'll go to 32. Okay. And let's add another binding for the what was it, radius? That's bound to the value. Title or label here of radius. And this one is the radius of the circle. So this one I'm going to make a slider. Minimum value here of, let's just do 0, maximum of 0.5, step of 0.1. Oh. See here, I don't like that it's a fraction or a decimal value, because you know what radius is this controlling? It's controlling this circle radius, or at least it's controlling this step thingy here. I think it would make sense to have it be like an integer. Or we can give it a name of like a better name. Or we can leave it like it is. It looks really good on the back of it, these like shiny edges. Oh, and then what we should probably do is, you know, put controls for enabling or disabling this. So enable true. Down here, we'll do select, enabled. If it is enabled, we'll do that. Otherwise, we'll do this. No, we need to add that to the bindings or to the pane. And I don't think we have to say that it's a Boolean. Yeah, it's just a checkbox by default. That's nice. Okie dokie. Still got some time left for sure. Let's see, what else can we do? So in this example here, I mean, I could do it. It's pretty simple. This luma value, this number will give you, the dot product says how similar are two vectors. So how similar is this color RGB, whatever they're getting out of their sampling here, with this luma value? And then using that as the radius here. So you don't want this to be 0, I guess, or if you do, I don't know. But you can see each of these circles now has a different size, and the brighter ones are larger. So wherever it's really dark, like here, it's not so bright, or it's not so big. I think ours will have a lot of big ones because there's a lot of shininess to this image. But this will be really easy to do. We'll do the dot with vec3 0.2126 0.7152 0722. And before we do this, we get the color out from here. Yeah. This needs to be right here. RGB. Okay, we got our luminance now. We apply it to the radius. So this is a ini. That's weird. Oh, that's because dot needs to be imported. So we can take the radius and we can multiply it by some luminance. And that's our new radius that we pass into the smooth step here. Or this, in our case, step right here. But if we do this, then we have to bring everything up to the top. Put this here. This will go up here. Here where we turn the color. What or number? Oh, okay. I see why. So we need to turn it into a something we can multiply with. Or we can take the lum and multiply that. Multiply that with, what was it, radius? We do that? Okay. Yeah, we're good there. Oh, some of these look like blocks. That's strange. That's probably why they do that 0.1 thing. Or not, I don't know. Some of these are just blocks. Oops. Oh, that might be because it's smooth step that they're doing. So we use smooth step. Let's do. Well, that's not really lum anymore if we do that. Let's do radius. Let's do lum and 0.1. Multiply the radius. And here we'll take the r, we'll take minus, what was it, 0.1 or 0.01? And it's the distance. Oh, what did I do? Yeah, I still get these blocks. I'm not sure about that. Like right here, look at this. So let's think about this. If it is like a value of 1, holy. I don't know. I don't really like it. But you get the idea. I don't like it because of the blocks. So I'm not gonna do it. Go back to what we had before. Okay, what do they do next? Grid UV offset. Oh, okay. This is what I was kind of curious about. It's how do they, um, the example here, do they offset it, each of these by some amount? Oh, they do get blocks in theirs. Yeah, look at that. So rather than like a grid, that last soundtrack was pretty good. Um, but each like row, you get the row index, it seems. And you know, if it's a positive or if it's a odd number, then you offset it one way. If it's even, then you offset it the other way. Uh, so yeah, how do you know what row? Like if you're even or odd? You take the UVY. This will give you a number between um, you know, 0 and the size of the, what did we say about n here? So n is some fractional number, but if you take that and apply it here, yeah, so this will give you some number between 0 and this number here. You know, in the end, it's going to be an integer. And that's what you need, because taking the mod of some floating point number seems kind of weird. You want this to be an integer. And that's probably why they floor it, too. But it'll be some number that's not, you know, less than 1. And then this will return either a zero or 1 here. So it looks like every either odd or even row gets shifted. Okay, so let's try this out. Take the UV dot y dot div and dot y. And then we'll take that, and then we will mod it by 2. That's our even or odd check. So now we have a number 0 or 1. To shift that to yeah, we can just use that. You know, turn that into a float and then use that as the multiplier. So in that case, we'll get the offset UV, we'll do UV dot X. Can I just do equals here? Yeah, okay. Looks like I can. Offset.x. That's in dot mul 0.5 dot multiplied by this row, which is even or odd. Or what do they call that? Parity or something? I'm gonna call it even or odd. Or actually, this is 0 or 1. Oh, this needs to be add a sign. Row, this is... Oh, I already did it here. Okay, that's not right. So in the X, we'll do this. And in the Y, we'll do nothing. And then we'll use the offset UV for the cell UV, I guess. Or do we use it for the UV pixel texture here? Yeah, that's not right. Oh, I need to floor it here. Forgot to do that. Okay, make sure this is right. Take the uv.y.divide by n.y, yes. Floor it. Then we'll mod it by 2. That should give us a 0 or 1. Okay, so here they are using offset UV here. So I guess you do want to offset everything? It's messing up on like the even or odd, one of the even or odd rows or something. Oh, this should be... Yeah, this is wrong here. This needs to be .x, I think. No. Let me jump over here. I wonder if I have to take this as a vector too. Yeah. So that's a little tricky. If you don't pass in anything here, like this add function, I guess takes just this first argument and it adds it to the x and the y. It will ignore this one, I think. But doing this seemed to fix it. But now we have something that we can you can control the offset or whatever, right? This just offsets it on the x. But now you could do some weird things, like you could move these circles around over time or something like that. This is starting to get a little too much, I think. This is a lot of code here. And if you're not used to reading it, you know, these chaining methods or whatever, it's kind of hard to parse it in your brain. Now we can clean it up a little bit. Dang it, I hate this. Why can't I select it? Whee! It looks like somebody's ear right here when you tilt it like this. Here's the weird thing about the orbit controls, is that I have no way to orient this thing such that this circle here is right here. Now if I do that, like I'm looking at the front of it. And I have to rotate the object now instead of the orbit controls. That's a cool effect. Ooh, these are nice. I wonder what these are doing. Yeah, they do like rings. Whoa. Hmm. This this will be fun to see if we can get this implemented. Whoa, look at this. Oh, this looks a little complicated, but we'll get there eventually. Hmm. Okay, well, we got ways to go to get there. So I guess that's it for today. Uh, Next time it looks like take a look at what is this? Yeah, we'll just keep going through this article. Try to recreate most of these scenes. This is a video, isn't it? Yeah, it looks like you could use a video texture or something. I really like this one. This will be cool to implement with these rings and stuff. So there's a lot still to go through in this article. Again, if you're interested in it or reading about it, I'll paste it in the chat again. But we're just going to continue with this. So this will be Tuesday stream. And then, yeah, I think next week I'll be Tuesday and Thursday. It might be just kind of like unprepared streams, so it might just be kind of like it was at the end of this stream, where it's just like me fiddling around with it, and you get to see how my brain works. I guess you get to follow along with that sort of thing. It is time for lunch, so that's what I'm gonna go do. If you're here, thanks for watching, and I'll see you guys on Tuesday. Have a good day.